Hi everybody, we're doing derivatives of logs and I wanted to start actually by looking at their examples, they're good examples. A good one to start with is actually 1b, I didn't want to do that. Here, so it's log 1 minus 3x. Right, what we've gone through so far is to say if the function is y equals log x, the derivative of that is 1 on x. From there, every question kind of becomes a chain rule. We had 1 minus 3x, I think, or something similar. So the procedure is take what you log in, like here it was x, and do 1 divided by that, i.e. 1 divided by 1 minus 3x. So whatever you log in, do this step, then treat it like a chain rule. That was like the outside part. So this is the whole thing that got logged. But on the inside, the x was multiplied by 3 minus 3 and the 1. So you think, well, what's the derivative of the inside? It's minus 3. And you can whack all that together in one fraction. So that's a good starting point. In their example, they've also got a product rule, I notice, over here. So I might, UV, where u was x cubed, meaning that u prime has to be 3x squared. V is log x. Derivative of log x is 1 on x. And then they're building their derivative using the product rule, right? Which is OOV plus OOV, and hopefully you haven't forgotten that. So that's what's happening here. In this one, maybe you would write it out with an extra step. Just before I go to that one, right at the end here, they do their 3x squared times log x there, and then they've got their x cubed times 1 on x, which simplifies, they show it here, simplifies to x squared. They've noticed there's a common factor here, right? So they've factorized. And if you were answering a question that just said find the derivative, you could actually leave it here, and that would get you 4 marks. However, if you were then going on to use that equation, I would certainly tidy it up into this form. It will be easier to work with and find when it equals 0 and things like that. This one's kind of interesting too. The k's cancel out. So if we follow the procedure I was just talking about, whatever we're logging, we're going to do 1 over that. And then we're going to multiply, we're going to go on the inside of the function and multiply by k, and you'll see k's cancelling, which just leaves 1 on x. Okay. Please also look at example 13 in your books. I'll just briefly discuss. I probably don't. Hang on, it won't let me go down. Let me try that again. Yeah, scroll down. So what they're doing here is they're applying log laws to make this a lot easier to differentiate. These questions are different to something like this. You can't break up that log. Here we've just got log x, but down here I've got log of something times something, and they're showing that here. Log of a times b could be written as log a plus log b. If you go through this example, that leaves you with something that's easy to differentiate, right? Similarly here, they're simplifying the log. They're saying I've got log a divide b here. So they're separating out the logs. Then they're noticing that in log b, you still had something times something. It's here. You still had x plus 2 times x minus 3, so we can break that apart using log laws. We're using this one now. Just be careful because you need to subtract all of this, hence these brackets here and here, right? So look at those examples and let's do a couple of questions ourselves. Next page. I might start with maybe 1C. I was going to do C. I think I'll do H, L, maybe O as a good comparison, and I'll try and fit them on the page. So if we look at C, there we go, and say its derivative is 1 on whatever we're logging multiplied by the derivative of the inside of this function, which is minus 2x plus 1, or maybe I should have written 1 minus 2x would have been more logical, because when I make this all one fraction, it'll look better like that. Yeah, all right, so that was C. Just clear the air. Let's get rid of that and do another one. I thought I could do H. I wanted to point out with H that this is log x all squared, not log of x squared, right? So treat this as a chain rule. You need to say I've got 2 log x, so I'm taking the 2, put it out the front, minus 1 from it, and then I'm going to multiply the derivative of log x, which is 1 on x. So to tidy that up, 2 log x all divided by x. Okay, I think I'll look at L and O. Yeah, this is a good one to do a quotient rule on, I think. If you need reminding. So question L I might be rewriting as y equals u on v, where my u is 2x to the power of a half, meaning my u prime is half times 2 is 1, and then we subtract 1 away from our power. And our v term is just log x, and the derivative of that we all know, 1 on x. And then I could apply quotient rule, which hopefully you have memorized. V squared, so that would be OOV, x to the minus a half, so we get log x on square root x, right? So x to the minus half is 1 on square root x. Then we have a minus. We need to combine a 2x to the half and a 1 on x. That's a 2 root x and a 1 on x. And then that whole thing has to be divided by log x all squared. Now this could do with a bit of tidy up. This 2 root x on x, just consider that for a minute. Consider 2 root x on x, well that's the same as 2 on root x. Here we've got a power of a half. Here we've got a power of 1, so we do half minus 1 is minus a half, and there's our power of minus a half there. It's starting to get a bit messy, I'm going to erase that. So to tidy this up, I could actually have a common denominator within the numerator of this fraction. I'll have log x minus 2, all divided by log x all squared. I still want to keep tidying this up. I'm going to multiply. I think I need more space. So if I took this, let's go over here. We've got log x minus 2 on square root x, all divided by log x all squared. I don't like having the fraction within a fraction, so I'm going to multiply my fraction by root x on root x so that these cancel out. And then I'm just left with the derivative equals log x minus 2 all on log x all squared, which is, there's a bit of work there. It's left me wondering if it would have been easier to use product rule. Anyway, too bad. Done it now. That was the answer. Maybe we can show product rule when we do O. So I could rewrite this function as log x times x to the power of minus 2. And I'm saying this equals some function u times some function v, where the u is log x and the v is x to the minus 2. So u prime is 1 on x, v prime minus 2x, subtract 1 minus 3. Right, so the derivative there is that times that, so of 1 on x times x to the minus 2, which will just be 1 on x cubed. And then we have to plus in product rule, although that will turn into a minus because I've got log x times by minus 2 x to the minus 3. So to clean this up, it'll be minus 2 log x on x cubed. We've ended up with the same denominator, which is nice. So let's write it as one fraction. We get 1 minus 2 log x. Okay, so that's probably enough just to get you started on that. And I'll leave it there for now.